Welcome to it on. So this is the video in the continuation of our complex number series. So in this video, the first topic of the day is simple and multiple connected region. So first of all, we're gonna talk about simple connected region. So what is a simple connected region is that a region in which can be shrunk to a point without leaving. Let me explain. Suppose this is a curve. This is a region R and this is a region R1. So if we make this curve shorter, so will it turn to a point? Like we make it shorter to this, then we make it shorter to this. So eventually it can shrunk to a point. So this region which can shrunk from any size to a point is known as simply connected region. So you can see, suppose there is a region a tau, we can say that this is the boundary of a circle which is radius z. Suppose this is a radius, so with radius z, this is the boundary of the curve, this is the region. So now you can see that this region can also be reduced to a point. If we decrease the volume of this region, it can be reduced to the point. So this is simply connected region. Now let us see multiple connected region. So what is the multiple connected region? A region which is not simply connected. Suppose this is a region. This has a blank space in it. Or you can take an example of a donut in it. Blank space. So can a donut be reduced to the point? No, because if it reduces the point, still it will have this blank space in it. So it is multiple connected region. So it have holes in it, but simply connected region can never have any hole. So moving to the next topic, before moving to the next topic, let us again illustrate. I already explained you, let these are two holes and suppose this is the circle with radius z. Now this circle cannot be reduced to 0 because of these holes, because there are always a holes present in here. Now let us talk about Jordan curve. So any continuous closed curve which do not intersect itself and which may or may not have finite value. So what is this? Suppose this is a curve. So if it intersected like this way, so then it is never called a Jordan curve. If it does not intersect and maybe finite may not, then it is known as Jordan curve. A curve which is in this form is not a Jordan curve because why? Because it intersects it at this point A, suppose. So the curve which do not intersect itself is known as Jordan curve. So there are the three postulates basically of a Jordan curve theorem. So what happens in Jordan curve theorem? First condition is ours. Here are the two conditions is written and the third which is missing is that the curve should be Jordan, because as name suggests this is a Jordan curve theorem. So let's suppose this is a Jordan curve with radius z. It has a radius of, it's a circle, it has a radius of z. So what does it do? If we take z, it's less than m. Because this is the boundary, let's suppose this boundary is m. And let us take a value of z outside the m. So what happened that this Jordan curve at boundary m divide this whole plane into two parts. First outer region and second inner region. So what is the interior? Here, when z magnitude is always less than m. where is the exterior curve? When z is always greater than m, that is outside the curve. So this is the Jordan curve theorem that basically suggests that if the curve is Jordan, then it divided the Jordan curve plane into two parts. First, interior where z is less than m, and second, interior where z is greater than m and where m is boundary. So now let us discuss a conventions regarding a transversal of a closed path. So transversal of a closed path means that how it gonna be, vibrated, or how can we see the negative and positive signs on a closed path. So the boundary C of a region is said to be transversed in a positive direction if the observer is going into left direction. Suppose this is a curve, and suppose it is a stationary curve and the object over here is stationary. So if the object mover moves from here to left, then it is said to be have a positive direction. Or you can say, if it has an anti-clockwise movement, then if it is an anti-clockwise movement, then it is said to be in a positive direction. Direction is always indicated by arrow, as word suggests, either it is anti-clockwise or clockwise. We use special symbol to integrate. We know that if there is a curve is closed, so instead of written it as curve C, we can write it as closed curve C, and this is called contour integration. The positive direction is left side and integral around it is called contour integration. See, this is contour integration C fz dz. Now green theorem in a plane. So what is a green theorem suggests that if there are two parts P and Q, then what happens is it becomes that single integral was converted into a double integral. We all know this green theorem in plane. We just take here to take a reference with respect to the complex number. So complex form of green theorem becomes such like this. Let's suppose we have a function of fz or fz conjugate. So then if we have to convert it in a double integral, then it becomes 2 iota double integral over region R function differentiated with respect to z conjugate and dA. Integration whole with respect to dA, where what is dA is dx into dy. So it is just a formula to revise. There is no derivation in our syllabus, so we are not going to do it. I hope you understand today's topic. Thank you so much and keep watching this series.